Hi there! For today's math video, we are going to talk about integers and how to solve many different types of problems using integers. But before we do that, let's take a look at this number line. You'll notice that there are some numbers to the left of 0, which we read off as -1, -2, and so on. Don't worry, we'll explore those later. For now, though, think about this question. Starting from 0, take 12 steps to the left and 6 steps to the right. Where do you land? What do you think? Take a moment to pause and think this question through. Let's go ahead and draw the situation. Starting from 0, let's move this dot 12 steps to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now, let's move the dot 6 steps to the right. 1, 2, 3, 4, 5, and 6. Our dot lands on the number -6. Did you get the question right? We can actually think about this problem as an additional problem with integers. What is an integer? We'll get to that, but we need to review some definitions beforehand. Understanding what a natural number is key in understanding what an integer is. Remember when you learned how to count? 1, 2, 3, 4, and so on. We can call these counting numbers because these are the numbers we use to count. But in math, we like to call these natural numbers. Natural numbers are positive whole numbers. Now, let's copy down these numbers and put a negative sign to the left of each of these copies. Any number with a negative sign in front of it is called a negative number. So the numbers in red are examples of negative numbers. Any number without a negative sign is called a positive number. Thus, the numbers in blue are examples of positive numbers. Sometimes we write positive numbers with a plus sign beforehand, but it is not required. When we are talking about negative numbers, though, we will always put a negative sign. When looking at a particular number, we can get what we call the opposite of a number by changing the sign. For example, the opposite of +6 is -6, since we are changing the sign of 6 from a plus sign to a negative sign. Pause the video and think about what the opposite of 12, -29, and -2023 are. If you thought the opposites were -12, 29, and 2023, you're correct. Now that we have opposites down, we can now define what an integer is. An integer is the set of all natural numbers like 1, 2, 3, and so on. Their opposites and the number 0. Let's think of some examples and non-examples of integers. 12 is an integer because it is a natural number, also called a counting number. -26 is an integer because it is the opposite of a natural number, 26. 5½ and -0.99 are not integers because they are neither natural numbers nor opposites of natural numbers. Just like whole numbers have an order, 0, 1, 2, 3, 4, and so on, integers have an order as well. Using this number line as a visual for integers, let's start by marking down the whole numbers in order starting from 0, 1, 2, 3, 4, 5, and so on. Now for the opposites. We're going to start from the left of 0 and write -1. Moving to the left, we'll write -2. Moving to the left again, we'll write -3. And we'll continue this process onward. This gives us an ordering for integers. We can read off some examples from the number line. 5 is greater than 3, 1 is greater than -3, and -5 is less than -2. Can you make other observations? So what can we do with integers? Remember all the operations you learned in the past? Like addition, subtraction, multiplication, and division? Well, we can do all of these operations with integers. Before we learn how to do these, though, we need to talk about absolute value first. The absolute value of a number is the distance between a number and 0 in the number line. For example, 4 is 4 units away from 0 on the number line, so the absolute value of 4 is 4. -3 is 3 units away from 0 on the number line, so the absolute value of -3 is 3. Mathematicians don't like to write out the words absolute value, so they generally write 2 vertical bars around a number whenever they are talking about that number's absolute value. When computing absolute value, we don't necessarily need to graft a number line. Notice that the absolute value of a positive number is the number itself, and the absolute value of a negative number is the opposite of that number. Pause the video for a moment and think about why that is. Let's do a couple more examples. Without graphing a number line, can you determine what the absolute value of these two numbers are? If you got that the absolute value of 13 is 13, and that the absolute value of -23 is 23, then you're right. Next, we'll be moving on to performing some operations with integers. Let's start with addition. There are 2 cases for this. In one case, you are adding 2 integers of the same sign, and in the other case, you are adding 2 integers with different signs. Let's go over the process of addition for these cases one by one. When adding 2 integers with the same sign, like the addition problem -10 plus -20, we'll need to do 3 steps. Our first step is to keep the sign. The final answer for this kind of addition problem will have the same sign as the 2 integers you are given to add. For the second step, write down the absolute values of the integers you are adding together. For the third step, add the absolute value of the integers you are giving to add. Let's try this with the example of -10 plus -20. Remember that -10 and -20 have the same sign, so we should use the steps that we just introduced. We need to keep the sign, so let's write down a negative sign to start our answer. For the second step, remember that we need to add the absolute values. The absolute value of -10 is 10, and the absolute value of -20 is 20. Adding those 2 absolute values gives us 30. So we can write down 30 next to the negative sign. Thus, -10 plus -20 equals -30. When adding 2 integers with different signs, like the addition problem -12 plus +6, we'll need to do 3 steps. For the first step, write down the absolute value of the integers you are adding together. For the second step, use the sign of the number with the larger absolute value. Write this sign next to the equal sign where our answer will be. For the third step, subtract the smaller absolute value from the larger absolute value. Then you're done. Let's try out these steps with the problem -12 plus +6, starting by writing down the absolute values. The absolute value of -12 is 12, and the absolute value of 6 is 6. -12 has a larger absolute value, so our final answer will have the same sign as -12. So let's write down a negative sign to start. Let's now subtract off the smaller absolute value from the larger absolute value. Subtracting off 6 from 12, we get 6. Writing 6 down next to the negative sign, we can see that the answer to negative 12 plus 6 is negative 6. Notice that this problem has the same problem we started off this video with, but using the mathematical symbols instead of words. The negative 12 can be thought as moving 12 steps to the left of 0, and the 6 can be thought of as moving 6 steps to the right. Where do we land? We land at the sum of negative 12 and 6, which is 6. Here's another example. Negative 3 plus positive 15. Our first step is to write down the absolute values of the integers we're adding up, which are 3 and 15. Here we can see that positive 15 has a larger absolute value, so our final answer is positive, and we'll write a plus sign to start. Now, we need to subtract off the smaller absolute value, 3, from the larger absolute value, 15. 15 minus 3 is 12, so our final answer is positive 12. Remember that we don't necessarily need a plus sign to say that a number is positive, so just writing 12 is perfectly okay. Now let's talk about subtracting integers. The process for subtracting integers actually involves addition. When you see a subtraction problem, you should first change the subtraction symbol to an addition symbol. Now, change the integer you are subtracting off to its opposite and solve the addition problem. The answer to this new addition problem is the answer to the original subtraction problem. Let's try this process out for negative 30 minus 6. For our new problem, let's change the minus sign to a plus sign and write down the opposite of 6, which is negative 6. Thus, our new problem is negative 30 plus negative 6. Our original problem and our new problem will have the same answer, so let's do the addition problem moving forward. Negative 30 and negative 6 have the same sign, so we need to keep the sign and add up the absolute values. Both numbers are negative, so our final answer will be negative. Let's write a negative sign down. The absolute value of negative 30 and negative 6 are 30 and 6, so adding those numbers gives us 36. Thus, negative 30 plus negative 6 is negative 36. And we can also say that negative 30 minus 6 is negative 36 too. Let's try this one. 4 minus 17. Let's create the new problem by first changing the minus sign to a plus sign and write down the opposite of positive 17, which is negative 17. Thus, the new problem is 4 plus negative 17, which will have the same answer as the original problem. Let's proceed with the addition. Our addition problem includes two integers with different signs, so we need to take the absolute values. Take the sign of the integer with the larger absolute value, then do a subtraction. For the absolute values, we can see that the absolute value of positive 4 is 4, and the absolute value of negative 17 is 17. Negative 17 has the larger absolute value, so our final answer will be negative. Now, let's subtract off the smaller absolute value, 4, from the larger absolute value. 17 minus 4 is 13, so you can write down a 13 next to the negative sign we wrote down earlier. Then, 4 plus negative 17 is negative 13, which means that 4 minus 17 is negative 13 as well. Let's move on to the rules for multiplying integers. How can we do this type of problem with integers? Let's move at negative 3 times positive 9. For the first step, we're going to think about the sign of our final answer before even doing any multiplication with the numbers. Look at this diagram over here. I'll explain what this diagram is trying to say. When you multiply two positive integers together, you get a positive integer. When you multiply two negative integers together, you also get a positive integer. When you multiply a positive integer and a negative integer together, you get a negative integer. When you multiply a negative integer and a positive integer together, you get a negative integer as well. To summarize these rules, if you are multiplying two integers with the same sign, you get a positive number. If you are multiplying two integers with different signs, you get a negative number. So, for our problem, -3 times +9, we are multiplying a negative number by a positive number. Thus, our answer will be a negative number. So let's write a negative sign down. Now, let's actually multiply some numbers. For the second step, we're going to pretend that both numbers are positive and multiply those numbers. Then we'll write that product down next to the negative sign we just wrote. So for this example, -3 times +9, let's think about +3 times +9. This is a multiplication problem we are used to. 3 times 9 is 27. So let's write a 27 next to the negative sign. And we're done. -3 times 9 is -27. Let's do another example. What is -5 times 3? First, let's think about the sign of our answer. The signs of -5 and +3 are different, so our answer should be negative. So let's write a negative sign down. Pretending both numbers are positive, we get 5 times 3, which is 15. So we should write 15 down next to the negative sign. Thus, -5 times 3 is -15. Here's another one. What is -12 times -5? We are multiplying a negative number by another negative number. These numbers have the same signs, so our answer will be positive. Let's write a positive sign down. Pretending the numbers are positive, we get 12 times 5, which is 60. So our answer is positive 60. Remember, since the answer is positive, we don't have to keep the sign in our answer, so just writing 60 is fine. Now that we learned about multiplication, let's look at division. You'll notice that some of the rules will feel pretty similar to the rules we had for multiplication. Let's look at 56 divided by -7. Like in multiplication, we're going to start by thinking about the sign of our final answer before even doing any division with the numbers. Look at this diagram over here. It should look familiar. I'll explain what this diagram is trying to say. When you divide a positive integer by a positive integer, you get a positive integer. When you divide a negative integer by a negative integer, you also get a positive integer. When you divide a positive integer by a negative integer, you get a negative integer. When you divide a negative integer by a positive integer, you get a negative integer as well. To summarize these rules, if you are dividing two integers with the same sign, you get a positive number. If you are dividing two integers with different signs, you get a negative number. This means that for our problem, 56 divided by -7, we will get a negative sign in our final answer. Let's write down a negative sign where our answer will be. Now, we are going to pretend both numbers are positive and do that division problem. Once we're done, we will put our answer next to the negative sign we just wrote down. Looking at our example, we are going to think about the division problem. Positive 56 divided by +7. That's 8. So let's write 8 next to the negative sign. Thus, 56 divided by -7 is -8. Here's another one. What is -24 divided by -18? Since -24 and -18 are both negative, we will get a positive number. So, let's write down a plus sign to start our answer. Next, we need to divide +24 by +18, but that doesn't lead us to a nice number. That is, an integer. So let's just leave it as a fraction and reduce as much as possible. To reduce a fraction, remember, we need to think of the greatest common factor of 24 and 18, which is 6. We can now divide 6 on both the top and bottom of our fractions, which gives us a reduced fraction, 4/3. This example shows us an interesting fact. When dividing two integers, you might not get an integer as your answer. This is very different from when you add, subtract, or multiply integers. In those kinds of problems, you should always get an answer that is an integer. Let's do a couple word problems based on what we have learned. Isabel is at a clothing store and needs to make some returns on a few items she had bought the week before. When she gets to the store, however, she realizes that she wants to buy a few items as well. After making the returns and purchases, she receives the following bill. Notice that there are some positive numbers, which indicate returns that Isabel is making, and some negative numbers, which indicate purchases that Isabel is making. Will Isabel have to pay the store clerk, or will she receive money from the store clerk? Pause the video and try to come up with the answer. For this problem, we want to add up all the values: 30, 12, -4, and -16. If after adding up all the numbers we get a positive number, then Isabel will get some money back from the clerk. If adding up all the numbers we get a negative number, then Isabel owes money to the clerk. Let's see what the addition leads us to. Let's add from left to right, starting with 30 plus 12. We're adding two positive integers, so we get 42. Now adding 42 and -4, we see that we have opposite signs. 42 and -4 have absolute values 42 and 4, so positive 42 has the larger absolute value. Thus, 42 plus -4 will be positive. Subtracting the smaller absolute value, 4, from the larger absolute value, 42, gives us 38. Thus, 42 plus -4 is positive 38. We need to do one more addition, 38 plus -16, and then we are done. These are numbers with opposite signs. Looking at the absolute values, we get 38 and 16. Positive 38 has the larger absolute value, so our answer will be positive. And subtracting the smaller absolute value, 16, from the larger absolute value, 38, gives us 22. Here is a summary of what we did. From this work, we concluded that 30 plus 12 plus -4 plus -16 is 22. This is a positive number. This means Isabel will be given money by the store clerk. She is one lucky customer. Here's another problem to think about. Phew! You have just completed a math test. On this test, there are 10 questions, and you got 5 points for every question you get right and lose 2 points for every question you get wrong. Your teacher has told you that you got 8 questions correct and 2 questions incorrect. What is your total score? Let's think about this one. You can either answer questions correctly or incorrectly. So let's think about the total score as the points from correct answers plus points from incorrect answers. For correct answers, remember that you answered 8 questions correctly, so that you gain positive 5 points for every correct answer. If we want to think about all the points you get from your correct answers, we should multiply 8 times 5. That's 40. Now, for the incorrect answers. Remember that you answered 2 questions incorrectly and that you lose 2 points for every incorrect answer. You can think of that as getting -2 points for incorrect answers. If you want to think about all the points we quote-unquote get from incorrect answers, we should multiply 2 times -2. That's -4. Remember, the negative sign comes from the fact that we are multiplying a positive number by a negative number. Thus, your total score, which is the sum of your points from correct answers plus your points from incorrect answers, is 40. the gained points plus -4, the lost points. Adding these two integers together gives us a total of 36 points. Good work! In this video, we learned about integers and how to add, subtract, multiply, and divide them. There's a lot of information, but with practice, you'll become a master of these problems. Remember, you should always ask for help if you're having trouble. Thanks for watching, and we'll see you next time.